Hey guys, this is 12.3 day 3 and it's the final recording of the year. We have made it. All right, so we're going to continue with our velocity problems here. Given the function here, d of t is equal to 3t squared, we need to find so this is a position function. We need to find the average velocity between t equals 1 and t equals 5 seconds. So average velocity, we know the way we write it is v average, right? We don't do v of t because that's known to be instantaneous, is equal to d of 5 minus d of 1 over 5 minus 1. So V average, when I take 5 and I plug it in there, it's 3 times 5 squared, which is 75, minus 3 all over 4. So V average is equal to 18. And because we're not given units for the position, it's good enough to just say V average equals 18. And then it says, find the instantaneous velocity at t equals 4 seconds. Well, okay, so V of t is equal to the limit as h approaches 0 of d of t plus h minus d of t all over h. Okay, so this is the limit as h approaches 0. What's d of t plus h? It's 3t squared plus 6th minus plus 3h squared minus d of t, which is 3t squared over h. 3t squares cancel, and now we have to get an h to cancel from everywhere. So finally, V of t is equal to 6t plus 3h. So V of t is equal to 6t. Okay, but what we want is V at 4 seconds. So V of 4 is equal to 6 times 4, 24. Okay, all right, let's do one more. This is the last ever problem we're doing. Okay, I think this is going to be a little tight for space, but we'll see. When an object is thrown straight down, the total distance y the object falls can be modeled by this formula, and we've seen that before. Y equals 16t squared plus v naught t. T is measured in seconds, and V naught is the initial velocity measured in feet per second. If an object is thrown straight down from a height of 816 feet, takes 6 seconds to hit the ground, what was the initial velocity of the object? So we are looking for the initial velocity here, which is V naught. And the object was thrown straight down from a height of 816 feet, right? So that is the position, right? That is the distance that it traveled. And so now when I have y equals 16t squared plus v naught t, right? Remember what y is? It's the total distance. Well, in this case, the total distance that it traveled is y equals 816 feet. The time that all this happened is 6 seconds, and so I'm looking for V naught. So I plug all this into my formula here. 816 is equal to 16 times 6 squared plus V naught times 6. And now when I multiply 16 times 6 squared, and then I subtract and so on, V naught is equal to 40 feet per second. Okay, so now that is the initial velocity. However, remember that this is an object going straight down, right? We have to signify that in our answer. So we say that the velocity is actually negative 40 feet per second because it is going in the negative direction. You yourself have to know to add that. Okay? All right. What was the average velocity of the object? Well, okay, so average velocity has to do with final minus initial, right? So it's y at 6 minus y of 0 over 6 minus 0. Okay, so let's just see what's going on here. Initially, this was where the object was, okay? And then the final position is here. Okay, so its initial position is at 0. Its final position is where? It's at negative 816, correct? Okay, because it went down, its final position is now at negative 816. So if you dig a hole 816 feet deep and then you now go down into that hole, where are you? You're at negative 816 feet compared to where you were before. So the average is equal to negative 816 minus 0 over 6, and that is equal to negative 136 feet per second. Okay. The next part is, what was the object's velocity when it hit the ground? Okay. When did this thing hit the ground? At what time did it hit the ground? It hit the ground at t equals 6. So what we're being asked here is, what is the instantaneous velocity at t equals 6? That's what we're being asked. Okay? All right, so let's remind ourselves, what is our function here? It's 16t squared plus v naught t. So what we want here is the limit as h approaches 0 of y of t plus h minus y of t all over h. This is the limit as h approaches 0. Y of t plus h, when you multiply everything out, I did it previously, it's 16t squared plus 32th plus 16h squared plus v naught t plus v naught h minus 16t squared minus v naught t. So that's the whole darn thing all over h. Okay, let's see what can cancel here. 16t squared, negative 16t squared, v naught t, v naught t. Okay, let's see if we can get rid of some h's. 1h, 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 1h. Now, this is the limit as h approaches 0 of 32t plus 16h plus v naught. So now v of t is equal to 32t when I plug in h is 0 plus v naught. Okay, that's the instantaneous velocity at any time. So can you see just from this that the object's velocity depends on only two things, not the time of day, not the weather, not anything else. It depends on two things. time and initial velocity, right? So the initial velocity that it started with and then how much time it took, that's what its velocity at any given time depends on. Extra information here. What we want now is the instantaneous velocity at t equals 6. So v of 6 is equal to 32 times 6 plus 40. And that is equal to 232 feet per second. But in what direction was this going? In the downward direction. So it's actually negative 232 feet per second. And that, ladies and gentlemen, is that. You can all take a bow. This was the last lesson of the year. Thank you so much. All right, now go and do your homework.